You want to stop near your
Let's see if mine's picking it up.
Oh, it's just okay. That's fine. That's expected. Yeah. That's cool. Oh, yeah. Presentation?
Probably not more than an hour. It's tough to say. It could be depending how interested people are about the conversation on some topic points.
Cool. Sounds good.
Like 40 people signed up. All right.
Okay. All right, we are going to get started. This is San Rover JavaScript. I'm Garvin, one of the co-organizers. Our other co-organizer, Tim, was unable to make it tonight. He's out with his kids. But we've got Ryan Paul presenting today on D3. And before we get started, just want to say thank you to Agilicis, who's our main sponsor, provides pizza for all of our events, and for Work Zones, who always is our home base for hosting us. So thank you guys. And one other thing, we've got, I think our last actually scheduled presentation is today. So if any of you have anything that you'd like to present on for next month or the month after, definitely just hit us up. Meet up for Learning to Code group January 10th, where we're going to be working on a joint project that we're putting together. So if you're interested, definitely check out that one. And without further ado, let's hear it for Ryan.
All right. right, so my topic is, or my presentation is about D3. As toyed with some of the examples on your homepage. If you haven't, has anybody here actually worked with D3 before? I mean, from fiddling to actually like full-blown graphics. So not that many people. Has anybody not seen some of the crazy stuff you can do with D3? All right, we're going to have to see some of this because it's pretty much magic. So you can get an idea of what D3 is by looking at some of the examples that are created with it. You can do everything from 3D spatial geometric projections to basic graphs to plots to essentially anything that you can, as a person, know mathematically to present or to populate. So D3 has an interesting problem domain because a lot of libraries, a lot of charting libraries, they offer features which D3, as you can see, has of presentation formats. There's no like constant action for all of these. So it's pretty incredible stuff. I mean, some of this, I don't know, the author actually didn't finish his college degree. He was working with economics and mathematics. But I mean, if you're going to go and create a library to do this, I doubt he needs much more schooling in the first place. So as you can see, this stuff is pretty gnarly. My topic, I'm titling it the Visualization Library for you. Because what you saw there, it seems like it does a lot. I mean, it looks like it does everything. Kind of doesn't make sense that we're kind of plotting this as like something that doesn't do anything for you. But I want that to be kind of like the theme, is like this thing doesn't do anything for you. And we can, as it does, to begin. And it says that it manipulates documents based on data. It helps you bring to life using all the standard web facilities. It is based on data, which, if you look at jQuery, it has sort of a similar feel. It mentions that it makes things basically easier or much simpler to use. And they have somewhat of a synchronization here between their problem domain. But the key difference really is jQuery is looking to just abstract and make things simpler, while D3 is specifically looking to act on your data. And we could take a look at on the general plane of all these libraries. You kind of get a good sense of what is the kind of consensus on like what is a library supposed to do. So these are all libraries, but these range from JavaScript to PHP to all kinds of like Ruby, everything that produces some sort of web format. And there's an interesting correlation you can make here. On the columns, you have different types of graphs, so they're all preset. They're like line graphs, scatter plots, bar graphs. So there's like a limited number of categories you can work with on most of these programs or libraries. And they all vary. Like some of them could do quite a bit, some kind of don't do much, they're very specific. The interesting sort of anomaly here you can see in the center, it kind of cuts right through there. Can you guess which one that might be? So there's like something kind of quirky there. It's like, how can this thing do everything? I mean, look at this. Like, it's like not even these guys are really close, but they can't even do everything. Like, what's going on? So we're going to look at a sample of some of these other libraries to try to differentiate, like, why are they so much different? What's going on? So here's one I just randomly picked called Charts for PHP. And most of these systems work in the same way. You're going to be calling into their library to create a chart object. And then from there, like pipe in your data. And then from there, you like tell it what you want, like on a line chart, bar chart, whatever. So it kind of abstracts all the details for you, which is nice. I mean, most of the time, if you're looking to just, they're perfect, everything great. And you can see kind of like set some of the properties, and then also you're ready to make professional charts. And then the equivalent in D3, there's really no equivalent. You can't just create a chart object. You're kind of limited to for you to do this manually. Sounds like a nightmare. It's like the worst thing you want in libraries for it to tell you to go do it yourself. And I agree, but saying all together in like one situation, it offers a huge wide range of helpers. From the mathematical standpoint, it has a whole between how it manages things and how you can do the math. So it has a very clean structure, which we'll get into. So there's a lot to it. You need all of it. Most of the stuff. We're just there to help you out. So when they say it's a visualization library, it's kind of a lie. The D3 offers a lot of, I guess we'll talk about frameworks versus library a little bit. It's kind of, D3 is split into two parts. It definitely has a library that reaching out to and use. And most of the library components are in the math department. And that's going, that gets into like scaling your numbers to, there's all kinds of math going to in there, and we'll get to that. But just keep in mind that there's a main component to the D3 behind, and then there's kind of like this other half that's more like the components that you can plug in and work with. So this part is more like a framework. You're going to be calling into D3, and you're going to be asking it to do some stuff. And it's kind of like this magical realm of, and we'll find out. We'll look into why this is all working so well. So the mechanics deep dive, we're going to play with some of the code. Because watching somebody hit buttons and talk about things is not very fun. So we're going to go into two parts. D3's kind of core mechanics is how you select your data. I need really specific here. How you select your HTML components, your view objects to be abstract, I guess. And then the other part of it is how you actually somehow connect your data with the view components. So, and then we'll go to rendering, which rendering is not really a thing. It's more like which are using Canvas or using SVG. That part you kind of is not related to D3, but you kind of need to know if you want to produce graphics. So nested selections, if you just want to read this, and then like I'll go get a beer and come back, it'll be good. So luckily, we're not going to be reading things except for code. Very basic code, mind you. We're not going to get too crazy just yet. So this may fall flat in my face because it worked well when I was sitting on my computer, typing and stuff, and we'll see how it works out here. So the core components are going to be selections, and then connecting your data to your selections, essentially. It's kind of a two-part thing here. And it does this in a really interesting way. And you saw so many amazing examples, which there's no way we'll be getting into those. It's because it doesn't define the implementation. To really manipulate data however you want. There's no abstraction for your charts or anything. Components here. This isn't very complex, and if you're into algorithms, this may not be the best choice, but if you're into structure, like raw data structure stuff, it's actually pretty fun. So we have here a basic table with each of these cells are embedded with a div or a p tag. Are there going to be HTTPS or HTTP? So we got some varying degrees of data in here. And with D3, it's very similar to jQuery. If you ever use jQuery, it has the abstractions where you can do like the easy selection. You can put really interesting selections in there. And then you can also edit you can manipulate the HTML by just doing style or CSS or attributes. Or it's an easy way to manipulate the HTML. And this one, it essentially copies from it. Mike, the author, had said that he was really heavily influenced by jQuery. The first thing you should think of with D3 is that you've pretty much already used half of it by using jQuery. So it's really not too much difficult to get the next part down. The selection is similar to jQuery. You can put in your CSS selectors. You can get away with some interesting stuff. So when I click the button, I have a handler set up that's going to execute this. It's 3 lines of D3. And you can see there's really not much difference at this point between this and jQuery. Very simple. Grabs it, no problem. We can play with the actual selection. Yeah, so that's strange. So why isn't it grabbing all of the items? If you want all of them, oops, I'm gonna break everything. If you want all of them or just one, there you go. So this comes into play in some of the next slides I'm going to do. There's a difference between jQuery here, where jQuery can give you back either one or just an array. This one, you have to separate. You have to give it more intent. You have to give it like exactly what you want. So similar, but not quite the same. Very simple, though.
Is D3 properties on Windows? Just like loading.
Yeah, we'll get like I want to get into some of the actual source code towards the end, and it's loaded. I mean, it's a massive object. Yeah. All right. So number 2. So it's kind of fun to play with single selections. But we've changed up our data a bit. Now we have three unordered lists with 2 items in it each. So go ahead and we'll do that same selection. We'll actually go and look at some of the objects that it's returning. To understand how D3 works, we get to look at the select object it returns, because it's similar to jQuery, but it starts to really take off from there as its own once you start looking at the object itself. Selected all the list elements. Boom. We're able to change the text, but we give it a function as the value to give the text. And you can see we just printed out the index, and you can see it matching up pretty well to what it would have selected, all 6 of the items. It's a bit hard to derive how that's working, but if we go into console, printing out the object right here, we can get a better sense at what's actually happening. Like, how are these selections working? It only has 2 properties on it. It has a groups and a parents. The only thing that's really relevant most of the time is just looking at the groups, because the selection will group whatever you select into an array. So since we did a flat selection and we just told it to select everything, it's going to do one basic array with 6 elements. Pretty simple stuff. So here is that one simple array. We'll know and list the 6 elements. And sure enough, you can see it's referencing the actual DOM object. So that's a pretty good look. You kind of see how it deals with jQuery does a little bit differently, but this one is fairly unique. Like I said, our half of, because it's like so simple to select things, what's so special. Half of the mechanics, they're synergized and they work really well together. So basic stuff, not too hard to learn. And there's no learning, we already know what's going on. So this one is double selection. What you can't do in jQuery is chain. You can chain all you want, but you can't chain any sense in jQuery. This one is unique because in the way it stores the selection arrays. So you can see here on the output, sucks. Anyways, colors are better. I'm logging the nested selection. So the big difference here is before we were printing out the attributes, which jQuery a lot, or sorry, JavaScript a lot. Is that familiar? Is there a function that you use that has a very similar callback signature?
Yeah.
You usually get back your item and then the index and then the array. So it's the same sort of concept. It's working on, as we saw, arrays. So it makes selections really interesting because you can really tune out what you're putting in to all these elements. And we can see that since we did a double selection, UL element as the parent, and then branched off, this is getting into like data structures, it branched off and selected the LIs as two branch nodes off of each of those LIs. And again, talking about it kind of sucks. So let's go look at it. Again, the group is where it holds all the selection data. And sure enough, we first selected those three ULs, three elements in the array. And I bet you if we open them, there's our two LIs. So it's mimicking, our selection is mimicking a tree essentially, which is very important for joining data or matching data up. Track of the organization, it keeps track of this hierarchy.
Was Warren said li.warren? Was that a class on?
Getting warmer.
Oh yeah, Warren.
Yep.
Gotcha.
I was deciding whether or not I was going to do something tricky like. So we selected the parent ULs, and then from there, selected only the warm LIs, which gave us back only what we wanted, and then it only applied our text. So actually, you can see it didn't select this one. If we go back into our objects, what do you think the group selection is going to look like? You think there's still going to be three ULs in there? Huh? Three. So there's that first one. Yep, sure enough, it matches up. So we selected the ULs. It's going to remember that there was three there. But since we only wanted a filter of those LIs, it's only going to fill up those arrays based on what it found. So it keeps that rigid structure, which is really nice.
Things guaranteed these order that is found in the DOM.
Yeah, so when it scans and it finds them, it's going to put them in as it finds them. And we'll get into a little bit about that later with our data, because that can become an issue later if you're doing it by just index, like what is your data? with this stuff shifts and oh my God, you're trying to apply data. It's going crazy. So that kind of brings us to the data in a certain way. Like we've kind of messed around selections, we kind of get what's going on. Let's try to log the data of the index in the array. Let's see what, let's just see what it gives us. Oh my God. You know what, let's make it easy. So we're going through and we weren't actually setting any text, obviously. I told it to just spit out the content. So it's going to find the LIs and for each of them spit out the contents naturally. It's just like map. See here that the data is undefined. And then naturally it has. So like data is like, where is the data? Like what's going on with the data? And like I said, the selections and the data are very much connected. They're very tight knit. So if we look at kind of like a review, I suppose, you can go to it's very much just like your basic data structures classic. You remember back in those days. But it's all just keeping the structure of your trees. When we did a flat search for the LIs, we have one array with 6 items. Naturally, the nested selection you're doing, making the parent sort of node, and then you're creating the subclass of the children. So it's fairly intuitive. Data work, and why are two people fighting? So the data gets a little confusing. Whenever you speak about data, most of the time you're referring to like some sort of system, right? From my Angular data is coming in. Usually you're referring to not just like the array you mentioned for the system or updating and all this kind of middleware, all this kind of encompassing the whole aspect of data. Data in this case, we're referring to just arrays, like just basic arrays. So your data is going to be like just a collection of information, strings, primitives. So when we hear data, try to think about like massive systems. We're just referring to just basic arrays. And you can kind of see why in a sec. So to look at some of the data, how does the system work? We have a way to select information, which is great. Like we need to know how to manipulate the DOM with these basic commands. But like the whole point is we want to get our data on screen and show some cool stuff. So what is the pathway that D3 takes to sort of bind this information? As we saw back earlier with that PHP framework, it was like make object, give me my graph or my chart. D3 doesn't make it so easy, but it's not very hard. So if you're into more complex data structures, then this is going to be your jam. Look at a few ways we can select and then apply information. And this is really the bread and butter of D3. This is where if you try to play with this on your own, it may take a few times really tweaking with it to really get the understanding. I'm hoping by playing with it here, you can just run home and like make some crazy 3D world of some sort. I didn't do very high math, so you guys are going to be the ones to do that. So we're going to define some sort of data set. Obviously, it's really small. It's like realistic. The data is going to be huge when you're dealing with stuff. In this case, it's just a 3-element array. Make sure that we know that data is just arrays. It's just play with this idea of data and connecting it with our selections. So the first thing we want to do is select what we want. And again, we're doing a flat selection. So it's just going to be 0 through 6. It's the same structure we have as before. And the only difference from before is we have this data function in the middle of this chaining. So without any sort of data, as we saw before, you can do selections and manipulations with data. Is now we're getting our data mapped into our selections. May not seem that big a deal, but it's really the core of how this works. And you could utilize this building any sort of graphics or charts or translations from numbers to visualizations.
Is that overstepping the ends of the array and just coming back to null for the bottom three?
Right. So what's going on? Like, why? How is it like? This is the black box. This is the framework. Like calling style, calling text, it's like very library. Like you're just like do this for me. But data, you're like, hey, like do something for me. Like you don't know what to, who knows what's going on. So the best way to kind of inspect what's going on, if anybody can guess, is in fact logging. So I saved the flat selection. It's been something with this data. We don't know what exactly is going on, but it's doing something because we can actually access this data attribute. We're getting the data from our array, and that's really the only difference is we've added the data. So like it's a pretty big improvement from what we had before. Look at what's going on. Besides the browser being really pissed off, we have not only our group and parents, but we have two other functions or methods. We still have our array. In this case, we only have 3 items, which is kind of weird because we told to select all the LIs. So we can already see that there's a difference between just a non-data selection and data selection. It's somehow figuring out how much data is in there and it's doing some stuff to it. So there's kind of some magic there. The next step would be, sorry, that music like kind of threw me off. I think so, it cheered me on. So yeah, so the next part is how is that data accessing? How is the text function accessing that data? Is it directly, is it somehow mapped that array, like referencing that array and it's somehow going through it? And we can actually kind of peer deeper into this to figure out how that data is being accessed. If we look at the actual LI element, again, this is just the DOM object, the DOM node. If we look real close, we can see that it's now got this underscore data with our lines, our value from our data, that first array, or the first element in the array. So that is something that data actually creates on the object. If we go back and we get rid of this thing, and look at that selection again, it's got all 6 now because it's not comparing it to the data anymore, and there's no data tree. Underneath the hood is like kind of not looking, just like pinning this thing up on there. So that's persistent, that stays. And that's something of interest. Whenever you make an attribute on a DOM element, it's like it goes away when you're done selecting that thing's on, and now it's on the object that's in the tree of the DOM. So that comes into play with something else that was kind of weird. That enter and exit is not there when you don't have the data. So the data is actually adding that enter and exit. But what are they? What is it doing? Well, if you notice, it limits what's in that selection. And we can kind of derive it based on the amount that was in that data array. Well, like what is, whoa. Groups, get away, okay. So if we look at the enter, it is, but we can see it's got 3 elements. So it's mapping it to the data length. So it's referencing some sort of data thing here, but it's got nothing in it. There's the length and there's nothing in it. Kind of weird. This one's got 6, so it's got the full length, and it's got 3 elements. And if we highlight them, we can actually see it's referencing those 3 that weren't selected. What's cool going on here? We can already kind of see that exit is really just meaning what wasn't. Like it's like a difference. It's like, well, it's something that was on the DOM, but it wasn't in the data array. So that's something really interesting, and this is kind of the core of D3 and how everything you're seeing is working, from simple charts to crazy 3D worlds and transformations. All of it is the core is right here. It's this sort of enter and exit, this difference. I call it like a difference engine. It's able to compare the data and give you back some relevant information. So we can kind of play with this. There's nothing in enter. And like, let's say we want to get data in the enter. We know that the exit is something that is on the DOM, but not in the data. Pretty much just need to reverse that. And I think we should get some stuff showing up in the enter. So we can do 2 things. We can do either remove stuff here so that we have less of our HTML than the data, or it can add stuff up here. And probably be easier is to copy paste this. It doesn't like it. Manual typing. All right, so we now have 7 elements, and we're selecting 6.
Do you want that data, Tom? Nice.
It's funny. I don't think JavaScript even cares, which is crazy. That's a big issue.
I wasn't sure. I mean,
So either way, I think we get kind of the same result. There's still some elements being shifted around data, and less up here. We can see like it's not really doing anything extra with the data. It's not like magically just inserting random stuff from there or anything. So it's only working within our data set. You can kind of see it's got the new values. It's cool. So now if we go in here, we should see if exit is taking stuff that's too many. Sure enough, the enter is pieces that are in our data that aren't quite on the DOM yet. So this is, like I was saying before, this is the core. This is how you do change in data in data state management. So D3 is more, it's not, the core of D3 is not necessarily a visualization library. It's a differentiation engine. So that's kind of interesting. I can look at some fancy. So data is the comparison engine, and we have a fun little get matched together. And as far as like visuals go, now what's going on, but just to kind of hit it home, we have our data set, and when things don't match up, there's an exit, and when there's too many things, there is an enter. It wants to enter into the HTML, into the view. So that kind of makes sense. Things would be exiting, and things would be entering. It's a pretty legit setup that he's got going. So
you can access like the extra arrays you go through these elements. So you finish all your data set and just run through all the extras.
right. So now you probably start to see these gears turning and how you can kind of manipulate documents. We'll look at, let's do that actually, that's a good idea. Now we know it's spitting us back information about our selections. Right now we have one in the enter, because we have too much data. So we should be able to then access that information. And they make it pretty easy. You call enter, not capitalized. But like, now what? Like we have enter. What is enter? Like what are we getting? Like if we're calling enter, what are we getting back? We kind of need to go back. Selection. The best way to find out what's going on is look at what's going on. So suddenly enter and exit is gone. Enter and exit is gone. That's because enter will essentially give you a new selection based on what it had found. So we're kind of back to ground zero. We're kind of like done this full loop. Now we have a selection again, which technically for a while we could try selecting more things and do nested selections. But sure enough, the group is that missing item. And it's an enter node, which is weird because that's not really like an HTML element class. But if you look at it, it's got the data. So it's got the data, that last missing element. Is it putting a placeholder there and then essentially waiting for us to do something with it? So all the manipulation functions now apply. We can do text, we can do styles, we can do anything we want. So we'll give it some content, some text. And we'll say like, I'm new. And we should see like some sweet new elements coming in. Anytime now, just give it a second. No.
Would you have to actually create elements and add it, append it to the DOM or something?
Right, because it was a placeholder. It technically wasn't linked up in the DOM tree yet.
Right.
Right, so just like you would with jQuery, you can append. Now in this case, we don't know what we want to append yet because it's just a placeholder.
Tell a paragraph or data from.
Exactly, we can tell it, put in the paragraph, and boom, we've appended something down to the DOM.
Oh, there it is.
So as many of the other libraries, this D3 really isn't even comparable to the other visualization libraries. They should have really, the author really should have named it something else because it can do visualizations. But in a way, it's not really, the core isn't really visualization at all. It's really just about difference, about taking your data and then figuring out what the state is. It's almost like a little MVC, a one-way MVC.
Instead of I'm new, could we have done like your lambda there and seen the E show up?
What do you think? Gonna work? We could break it. I don't know if I'm crying because my beautiful code is now defunct. Now, technically, we just want to deal with the data, so we don't really need the whole thing. And that's definitely not, that's the new Lambda syntax. There's the D. Down there at the very bottom. Yeah. So it's able to, so now you can kind of derive. All these styles and texts are no longer, they're not really associated with jQuery anymore. They're no longer that simple little humble changer. There's something kind of quirky going on where it's accessing, it knows to access that data element, and it's pulling information from it. So that's what I was saying earlier, is like there's this symbiosis between selecting things and data. It's really the core mechanic. And it has some interesting effects, as we're seeing. I can get even more complicated. We're doing a flat selection here. It's just like, boom, one array of 6 items. We're good to go. The data structure on our view side isn't just a flat array. So what if you wanted to like alter things of your data depending on which one you're in, you know, which parent you're dealing with? And that's where the nested selections we did earlier come into play. It just gets a little trickier when you're trying to access the data and deal with the data with these nested selections because we have these trees of parents. But we'll look at it because we're actually competent and we should have figured it out. At least I am. Not sure you guys. That was a joke. So a flat selection with flat data in terms of data structures, fairly simple. The next part is if you want to do nesting. Data 2. Flat versus nested. So as you can imagine with data structures, if you're not dealing with the same structure of data structures of arrays, it may get a little hairy because you're dealing with applying things and shotgunning them when you want certain things to apply, but not to the rest of them. So same structure on our elements on our HTML side. Nested ULLI like we did before. And then we're gonna apply our data set. Now that shouldn't work because it's like you have one array versus a nested. You have a nested array, you have one array is trying to like plug it all in there. Results, you can kind of see what's going on. So as you can see, it's not quite, it's working, but not quite like you would kind of think. Well, it is working like you think. It's just not very, it's not very helpful. So you get the relative indexes per item, but it's also, as you can see, applying that data set over and over again. So it's just shotgunning it for each one of these selections. And if we look at the console, we go to our groups that it's selected. And individually, the items. And as you can see, over and over again for each one. Parents. So that parents array comes in handy, because we can actually look at the ULs themselves. There's no data element here. So it's just applying everything and then just it's gone. It like heads out of town. So once you've selected something, once you start applying data, it'll stick to individual elements, but you're not going to get, per se, that whole data structure is stuck onto the UL. Like you might think it might be in the data or something. It only applies it to the individual elements. We can get even weirder with warming head. So now we're getting, so you can see it starts to get a little finicky. Like you really have to have a good mental model to understand how these data structures are applying to each other. It's only selecting the warms, which is the first one. But that's kind of weird because that's the second one in the data. They're in the HTML.
That's what applies.
Right. So this is where the indexing, it's just applying it by the index. Like technically, this one is index 0 on the selection that it found. So then it's applying index 0 of the data. So it's playing with this library. This is generally where things go to crap. Is like these don't make sense. I'm trying to apply it and like they're not connecting. So this is pretty much the biggest hurdle you'll have with D3. After you kind of get this sense of how the data is being applied to these data structures, it's just the math associated with scaling your graphs and like doing the X and the Y for all your values. Because if you can imagine that the data are plot points, are X, Y values with some other value. You can do attribute X equals D, like your data dot X, if you have like an X attribute in your data. I mean, you're just shotgunning these properties in there. You can go through like 500 plot points onto a graph, which is like with basically like a statement like that. And it's doing all the relative X, Y's based on the data you've given. So it does have a nice flow of whatever your data is, you can access it with this function with the data, whether it's an object with the hash map properties, or if you're just a raw array, you get access to all that. So it becomes extremely powerful. And we'll look at some basic stuff I did. So I did promise you I'd do some meetup API and possibly student credit cards. So watch out. If you start getting text alerts, that's why.
So I have a question about.
Yep. I was hoping to be a lot of questions because it's kind of quirky,
Yeah, so
quirky library. And I suck at presenting.
it seems like there's some coupling between the data set size and the HTML. Right? And then you've got these things that don't overlap in your selection.
Yeah, so it's like it's got these bins, and it's like, hey, these all fit in here. Oh, I got some extra over here, and that one's yeah.
One of my curiosities, though, is it also possible to just give it a bunch of data with JSON, have no pre-existing HTML elements, and then do all the rendering just from that? It seems like that's
Right.
so the way the web's going.
Right. So let's try something. Oops. So we just got rid of all of our data. We still have our data set. So start. Oh, we need D3. Just start with a bunch of LIs. Let's try to figure this out. So we have our data set. We select it.
Wait, can we just start with D3.data and data set? And then create the LIs?
Well, remember that the selection and the data work together.
Right.
When you have a selection, it creates like a nested array of some sort. And actually
Oh, right.
so remember, we gotta have something to match up.
So you gotta have something.
Right. So we gotta have, so this is now your question is like, well, what if you don't have something? How do you then?
Just one data element or something.
You would think.
One down the element to start with.
Or could that be anything?
So you are right, it needs some sort of element. And what's interesting is if we select this, technically we're gonna have nothing in our selection group, right?
Right.
But if we want to append something, it needs to be appended to something. So like, how does it, remember it has that parent array? Well, let's go look. Let's go see what happens when we select nothing. Thing to check out. So here's our selection. We have our enter exit. I'm assuming there's be nothing in here because there was nothing on the column. Sure enough, there's nothing. But so here's the answer to your question is, if we were to try to append something, where is it going? Well, it turns out it defaults to the HTML element. So that way you're not just
It's
like,
not necessarily to what? Why are you going to the body?
but yeah, but you never told it to.
Container.
But you never told it to.
Right.
So it has a fallback, which is kind of like in a way bad. Because we're like, why is my stuff appearing way over here? But in a way, it helps with different correction and stuff. So the thing on enter is when you have more data than that's actually alive. So sure enough, we have our enter modes. So just like we had before, we could append stuff. So we have our placeholders. We just need to figure out where, like, what we want to put in there at this point.
You say like enter and then.
Right. So the data is what's giving us the enter and the append. So you got to remember that the data is only just it's that comparison. It's taking things, looking at them, and saying, "Here, here's the results. Go do something. Have fun." So we just jam in a little append statement in here, and that enter or data. You want to append. Can be literally nothing in Excel works. An LI?
How that works, yes. It doesn't really need a,
So here's a question. If I do a div, is it going to be one after another, or is it going to be spaced out below each other? Is it going to go vertical or horizontal?
well, div by default is a block element, so there you
All
go.
right, just testing. Get some basic HTML knowledge.
All right.
Now, if you wanted it to fall back to body instead of, say, D3 dot select body, dot select all li, would it then fall back to body? Assuming body exists.
Yeah, the body's going to exist here. So we'll do, now there's only one body, right?
Right.
So we don't need select all, we just need select.
Yeah. Yeah, that double.
You know what, I want to hear it because it's doesn't work. What's that? So remember that selection is creating. So so selection on its own will return what it finds, and the length of the arrays is naturally what it finds. But when you do the data command, that's doing the comparison. It's going to give you back a new selection object with the enter.
Right.
So it's going to adjust the lengths. And
You
as
can select body, but the heights on the body, you don't get this height, it's fine to drive.
yeah, well, kind of. So that's where it gets a little tricky.
Now, if you didn't have to select all, I think you. Yeah, see the
Yeah,
heights went to the body element, then what was left over and enter with its fine to drive, which is not what you want.
Right.
That's why you want to select something that doesn't exist.
Exactly. Something like that. Yeah, because you're applying, because like what you're doing is well, see, it's kind of weird because it shouldn't actually, when you look at the selection, is the data returns. Found one item, and then it said, okay, well, we have three things we need to match up. Well, what I did was like, oh, well, that's already there. So that's in like the normal, that's not in the other bins. So then it just dumped the other two into the enter. And then it's like, and then now, so now it's attaching it to, since it has no base to the, it's attached to the HTML.
Right, so body is not parents.
Well, let's see. So body is technically one of the selections. It's not even a parent. So should be HTML. Body is just another item in your data selection. It has no special preference.
So the way to do it would probably be to have like an empty div. Select those nuts.
Right. Like,
That way you would be
yeah, like if you,
selecting something that's not there.
right, exactly. So yeah, you still kind of want, like, you want to leave your client side interaction programming to like create your data structures, like on your view stuff. You still want some structure, but like many Angular stuff, like a backbone, you can tell it to like use a template to create stuff. This is kind of like kind of defining the template, like right all in this one package. You're defining how many, you're defining, you get the added bonus of figuring out what is there, what isn't there. So you get this interesting sort of framework built upon these kind of simple data structure comparison concepts. So if you have a flat selection, if you do like just a regular LI, 6 LIs, you have a flat selection for your arrays, and it's pretty apparent what goes in and out on the selections. But what happens when we kind of saw what happened? We did a multiple selection on the UL and LIs, and we grouped them up into their own section. We got SPY, because it just applied this to each one of them. So now you should be thinking, what if we match the data, its structure with the other structure? Something more like that. And it kind of like combinatorially explodes into like, the deeper you go, the more complicated it's going to get. But if you do a nested selection if you do a nested data, like multiple arrays, and a nested selection, it actually matches up pretty well. And now we have to play with kind of the endpoint of dealing with your selections of data. I was just here. Anybody interested in this? Is this cool? Like hanging in there, not too rough?
Are you gonna make some really cool graphs?
Right. So I have some examples. Once we finish this one, we'll get into like seeing some actual visualizations. They're kind of crappy, but they're fun.
I just needed the carrot.
Right. And I suppose let's just screw it. Like, we already kind of know what's going on. So let's just screw it. You get too much into it and blow your brains out. Blah, blah, blah. So I could kind of want said at the beginning, it doesn't do anything for you, which is true. But realistically, it just doesn't make any implementation decisions. It just gives you like all the tools to be able to decipher what's going on. And then there's rendering, which is like using HTML. Canvas, nothing really special there. The mathy side of it, which is you have sets of math components. You can do, everybody understands scales pretty well. You have like an input, minimum, maximum, you get the output, maximum, minimum, maximum. You could, and how it gets calculated, it has preset options for you, a lot of preset options that make it really easy to like do bar charts. You can do ordinal band scale. So like it pre-calculates the width of the bands depending on how much space you need, all kinds of crazy stuff. So we'll look at that. We'll get an idea of what's actually going on by looking at some actual code for some actual stuff. All right, so my first attempt at some of this stuff was essentially just some simple graphs. And what else can I do? So what I have here is I have some of the meetup data. So I went ahead and called the reservation API and pulled a bunch of, essentially a bunch of user data about who signed up. It gives you a lot of information. It gives you like the time they signed up, their names, the little photo ID for your account, all kinds of fun stuff. So I figured we'll play with that. And so the data in this case is just one single array containing a bunch of regular objects with name equals all that kind of stuff. Very simple data set. There's no nesting, there's nothing crazy going on. So what D3 has on the math side of it is kind of the scaling built into it. So one of the unique things about the scales is you can do like linear scales, all those basic sort of scales, but it has a scale time. And on that chart I showed in the beginning with all the different libraries and all the different things it can do, rarely did they have some sort of time chart. So it's not a very popular built-in aspect of charting libraries because you can't really do time stuff. Something that this does flawlessly, and you can see here that that's just one of the built-in scales, the scale time. And I set the output range to be 0 and the width, which in this case is the size of one container. So all of the components of your graph are going to be defined separately. You get to intermingle them together. Thing for you, but it has all these cool tools for you to work with. So for instance, I could do push divided by 2. Hey, Donald Trump's here. Over. The axis, it has built-in axis functions for you to show the axis. The axis is it fully depends on the scale that you give it. So since I did a time scale, I told the axis to look at the time scale for all this information and data. So it's going to pull all the different interpolation points from the scale itself. So I don't have to worry about trying to divide freaking months up and like trying to figure that stuff out. Super easy, makes it super, super smooth. There's a convenient JSON method. It has a few of them for CSVs and TSVs and other stuff to pull in your data and automatically convert it to JSON. So I just pulled in the data. The data is like a epoch timestamp, so we need to like convert it to like an actual date object in JavaScript. I have it set so that I can change the time domain up above. Or if I don't want to deal with the timing, I can just tell it to use the extent function, which basically just gets the minimum and maximum of the data set. So like I said, there's a lot of these really cool tools in there to really get some statistics on your data. So I said to grab the extent of the data based on, if I go back up to my time domain and I just get rid of it, now it gives you the scale, the time scale from the very first setup to the very last.
Now, back and choosing the take intervals.
Yep. You just kind of set the axis up and say, hey, there's my scale. And it figures out what the best option is to fit everything in. So like as much as it kind of like lets you do, like doesn't really give you much to do it, it encapsulates it pretty well as far as some of the under the low level stuff. So that's something interesting is that I'm actually setting the domain of the scale at a letter point. So as long as you save reference, it's just returning you an object with a bunch of built-in methods. And those methods you can change at any time. So the time domain, I'm setting at a later point even after I create it. So that means that if you had data that's coming in constantly, you can call the domain or the range function, you can call these different functions depending on what the new data is, so that you can actually have things without changing any of the actual HTML. It's just dynamically generating the limits of all your data sets as it's coming in. So you can plug in the domain at any point.
We try changing the Y scale to IDX so that we kind of spread it out so you can see the names. So we all talk at the top of each other.
Right. So the self, I don't really have much of a Y scale on these ones. I have another example that I have that has some Y scales on it.
Or we could set it to the length of our data.
Okay.
So we could just basically say the first thing, if there's 100 things there, is there a Y scale?
I see, just do, okay.
Yeah.
We can do that. Now, what kind of scale would we need?
That's the meter.
Bingo. Linear scale. The range can be some sort of height. Yeah, we're to do, well, the output range. The output, we're going to want to match to our view.
Oh, got it. So it's going to be 0 to height.
Right. So in this case, SVG does. So to do the height, you have to kind of reverse it. Yeah, you got it. You seem like you've done some of this stuff before. You got it. In our domain, our input, well, it kind of depends on what we have. So we'll do that later. We'll figure that out right here. We'll say Y scale. So let's see, array, index. I guess all we need the length. So the actual domain will be 0, and then it depends on what you're looking at. So we just need the length of our data set, really. That's going to be the determinant. Or is it just data? But nothing's happened yet because we haven't really done anything with the Y scale. We need to actually, when it goes to set that Y attribute, we need to plug it in there so it can be scaling it around. So the actual draw function, the axis is pretty simple. We're translating it down. Spoiler. Names. Here's the core that we worked with earlier with all of our data sections. Nothing's different. Like the idea between altering data and producing numbers is no different than like simple HTML versus a bunch of elements. I mean, it's the same stuff. So on here, you can see the Y and the X are set right here. The height, remember, if it's setting the height, that means it's going to be the bottom. But what we want to do is we want to get the index. Or within the actual callback, it's going to pass us the index as a second parameter, like the map function. And we can say, well, if we just do I,
Should be Y scale.
yeah. You know, we want to scale the actual value. I'm going from height is 0 up to the length.
Do you have an extra D arrow there, or is that fucking wrong?
Right.
Oh,
There you go. That was a little close. It was hard to really see. Good catch. But it's a little arbitrary because
okay. Yeah,
people aren't necessarily in order.
right, right.
But there you go. So you guys just altered some of the data set. Wow, we just changed a few parameters. It's pretty damn cool. Not only that, but like the way this sets it up so that you're defining these individual pieces and then plugging them in together. It's kind of very raw, but it has such a nice wraparound for all these functionalities. Once you get the hang of it, I mean, I'd be interested to see what you guys would be able to make if you wanted to go ahead and give it a try. Like this is the most basic example you can ever do is like, I mean, that's nothing. But I do have a little trick up my sleeve. Is you can get, since the data that we're dealing with has more than just obviously the names, and we can play with other data attributes as well. I'm happy this because I really suck at making like subsystems, and it's in one system. So we'll change. I have a few functions to draw different things. There's a draw photos. So get ready to be embarrassed by all your pictures. Ta-da! So that's relative to the sign up time again. But that one's missing something. It's missing the Y. So we'll go down to the photo. Draw photo. I've preset a height. It's relative to the actual height of the graph. And actually, I've shifted the range. So you can see, like, you can do all the ranges and domains on the fly. So I've shifted the range because I want the output to not be on the very edges of like the picture that cut in half. And the range by half of the picture on each side. Pretty cool, pretty dynamic. Those of you who like do this all the time, I apologize, you're probably cringing right now. On the Y scale of the eye. Height. Now, if you wanted to, we could like scale the Y range to like crunch them in, but that's pretty good. Now, something interesting about D3 is it does have some helper stuff. So I've added in the ability to click on stuff and they disappear. That's a nice little fade. Make sure we get all of you guys in here. So on math and non-core functionality, as you can see here, I have the click handler on the on-click. Oops, not Sublime. So go to click handler. There's something really cool about one of the built-ins called transition. When the click handler executes, the this attribute will be obviously the HTML that's been clicked. Well, what's cool about the whole idea about the selections and the data, like binding that data onto like a data attribute, is it's going to pass the DOM node as the this reference. Whoever's attributes, whatever the object was for that person, attached to the DOM. And we can check it out. We can do console. And then we'll pretty much be almost done after this, just so you guys don't fall asleep. We'll do this. And with our previous knowledge we got, we should be able to see once we click something. Well, it's not going to show us because it's not the attribute, or it's not the actual element, it's the DOM attribute, the DOM. So here, we do this. Do the actual data attribute. There you go. Oh, you guys are here. So sure enough, here's the object. We can do it. We can pull it up. So there it is.
Just do it after.
So this is like, there's like whoever signed up, 40 of these objects floating around on each of those elements, tucked into that data tree. So what's cool is the whole enter update. You can really pivot which data is getting updated by what's actually new in the view. And when things do change, you have direct access to each of those elements in the data right there in the DOM to work with. So one more thing, this one's gonna be a little more dynamic. And if you guys want to pull out your phones, I have a little poll, a little voting page on me. If you want to go to secrets.ryanv.com/meetups. Well, oh wait, I misspelled.
You copied all every demo I ever done.
Right. So
So mad.
yeah. Well, surprise. Not working. Which is weird because I've used it a lot previously, but that's how it works. Bummer. Well, I have luckily a backup, so I don't have a live example, unfortunately, but I have one running on my VM. This works. There's something funky there. Yeah, my VM's running. I have the same code running on my Raspberry Pi at home with the same web server, same PHP version, everything. And the DNS was working fine on my house. I don't know. It does. The DNS works. It redirects it to my home IP, but then something quirky going on with my web server, I think. I don't know. Essentially, I want to show you guys. I use Firebase to hook up to store the data for the yes and the no values. And then using just basic D3 stuff like we've gone over, I was able to use the transition to change the X value or the Y value to change. As well as it's like transition for like 500 milliseconds. And so you get this cool. So each time each time the data gets called to update the HTML elements, the Y scale is recalculated to take into account the total votes to then scale, to use the scale function that now has the updated totals to figure out like where the bar should go. So that's where like it's nice because you can pivot around where these scalings and all these things are happening so that you can make sure that they get the updated information. You could do some really interesting stuff, and you can hopefully kind of see how some of the more complex examples you'll see is like simple kind of concepts of like what's coming in, what's going out. So you'll see a lot of D3 where like they'll have a row of letters, and then when the new data, the data gets randomized, and then suddenly like the ones that are no longer there get like they just move up. Those come from the bottom. It's like full enter exit sort of state difference, sort of difference engine. Yeah, I'm really bummed this didn't work with the one online because it would have been fun to see everybody sitting there trying to vote. But there's one thing that is interesting. I hooked up about the other attributes to the transition. My yes and my no. Pretty simple. It's got option and value. So if I push this on there. Nothing's gonna happen because I didn't rig, like I'm not, it's a direct access to the data. I don't have any sort of abstraction that like adds it up. So there's nothing quite fancy with this approach I'm taking now. But the calculations for determining the widths and the heights of everything is in the update function to recalculate this information. Boop. It kind of like, and did its thing. So I haven't changed any of the code that built this graph, but it's dynamically adjusting to all of the different environmental variables that are happening. And that's where the power of D3 really comes in, is like, you're building a framework. Like each of these functions is using that same scale function, but it just happens to get updated each time you click it, so they're all adjusting in the right way. It's like, you create your framework, your flow, to start piling in your data, like remove some elements, put more elements in there, and you pretty much set up how to handle all those. So that's pretty much the presentation. And too bad, I try to keep a lot of code going on. But does anybody feel like they really like that you just go home and start making some basic graphs? Is that pretty well oriented with how this function is going on? And then we'll go ahead and remove it. Paste it dot pop. And then what happened to that? By the way. All transition. Yeah. So I hooked up. I've actually built like an app around there, something you can get all kinds of cool stuff. But yeah. So, say what? Oh, right. Yeah, we'll just pop out another one. course, it's like error when you try to do that because there's nothing there anymore. Firebase is probably really angry at me right now. But yeah, so like if you want to take a quick peek at that code, I can. I'm not sure how much time you guys have left. But it is actually, it probably would be wise to check out quickly that code because it is a little more complicated and it looks a lot more daunting. Too bad once you get the fundamentals down. If anybody's not familiar with like operating systems, I'm using Linux and VirtualBox, and I'm going to use D3, Sublime Text to alter all of its text files. And it's just Samba, the file share. And I can access everything on the Linux box, just like another Windows machine. Really handy if you're like trying to set up like your own little web server and mess with it. So there's all my files in my Linux box. And I don't have to use like Vim to edit them, which is really nice. So I go to my poll. So here's my YSQL. So the actual update function right here, it's a bit longer because you're identifying different states that you're dealing with. Like you see, it's all the same stuff. My enter is appending a direct. So each time I add one of those to the data set, it's going to do the same thing we're doing before. It's going to add a rectangle and do a transition for the Y, the height. When it just matches stuff and it's not doing any update or exiting, it's just going to adjust the Y, the height, all this, the typical properties, all the heights, all that. So each time you click it, it's going to do a transition for all of these. So it's like, it's a very declarative style where you have to kind of know what you want to build first before you go in and start making stuff. But once you know what you want, this has a really simple and direct like interface for just popping in those components. Yeah, so D3 is scary at first because of those joins. Like, if you want to go and try to mess with like joining nested data, you're gonna really be struggling for a little while because it's all about this mapping. And it's interesting. Yeah, that's pretty much D3. That right there is exit update and enter. Those are like you're updating stuff, you're exiting, you're entering. That's D3.
I'm curious, you showed us something earlier, the 3D graph, like
Want to see the code on that one?
sine wave or polynomial or something. How would you plot a surface like that?
I don't have the math background.
Well, I don't mean the math of plotting.
Let's go look, actually. He has all the code for his examples.
I mean just the appearance of the surface. Like that.
So he does, there is like projections, he can do like mapping projections.
It's not like divs are like 1 pixel wide or something.
Right. So that's another point is we were dealing with HTML stuff when we were playing with it. And that kind of goes back to the rendering idea. Where is my, did I close it? Shoot. I think I might close my little poll. Okay, so this is all, you think it's HTML or SVG?
Yes, HTML.
Right. So we'll refresh it. Back to and sure enough, my code is saying, hey, append direct when there's nothing there.
Oh, so it's 3 recs and the same SVG.
Yeah, SVG is like the canvas. If you think that everything's encompassed in there, very similar to HTML. You just did just another tag, like it's SVG tag. and it's all within that namespace. And there's like a little bit of, if you haven't worked with SVG, there's like a little bit of trickery with like the group tag and like how you group things and then translate things. It's a little bit tricky, but it's not too bad. Yeah, so some of the really like complex ones, area and code. You want to watch some Sperm? So again, this is all using, most of these are just being updated. There's no enter and exit here. But they're using this sort of, this timeline, main loop to then translate, update these things real time. What's nice about all these examples is they have all the code, so you can go in and kind of peer at what they're doing. SVGs. Right. So the main body is an ellipse with a constant radius.
I've only seen SVG do 2D visualizations. Does it have concept of 3D, or do you then have to get into your own sort of D3 doing the projections of
Right.
3D and the 2D?
Yeah, so most of that sort of real-time heavy data flow stuff is done in Canvas, I've seen. There is a lot of, with the election happening, there's a lot of SVGs that are being made with apps of the states and all their voting and like transitions and stuff. So it's definitely possible to do heavy data with SVG. I'm not sure about the 3D part there. I know that.
Like D3 on New York Times site during the election.
Yeah, so Mike Bostock, like nothing has to be, D3 doesn't necessarily need to be animated. It's really good at just displaying connections between the times. I think this is one of my favorite ones. This is what kind of got me into like wanting to know about D3. Was this simple sort of like you could kind of picture the data structure. Years was an array, and within each of the years there was an array of all the presidents. You just took that parent, that first parent, and like use that to then determine the distances, the interpolation of like the points.
So this is done with D3.
This is D3. So you can see like he's using the first parent element that contains the first the year element or that year array with all the presidents. He's using that, the index almost, like we were doing before with Y with our index, and then plotting that along the Y, and then plotting X with the different number of presidents to kind of shift all these values around.
We'll talk about the relationship.
So Mike has worked at May D3. And he worked for New York Times making a bunch of different interactive graphs and visualizations. There's nothing spectacular about New York Times per se. You just happen to be working there where you're doing a lot of these cool, more people-oriented SVGs. A lot of the SVGs are this example site are like kind of arbitrary and really cool, but like you don't really do much. But this sort of stuff, he's done a lot of these different types of examples where he'll take a lot of real time and real data. You get to see some really interesting results about.
Helps along the whole data.
Right, he did. So yeah, like before.
No one's done more for the graph.
Right, no, he has. Like the history of D3 is he had ProtoViews, which was an earlier version of what is now D3. It was its predecessor. 2000, he was working on it from 2000 to 2011. So he's been in, he's just surrounded by like heavy maths and statistics and trigonometry, everything for, I mean, you look at how he explains if you end up how this works and how this works, how the data join works. And he has a lot of really cool custom little he's made to show you how like the elements will like turn into the parent or like turn into the child. the most intricate one I've seen. I'm done after this, but this one will absolutely odd me. If any of you guys are heavy into data structures and algorithms, he's pretty much like the god of computing. Be prepared to piss your pants if the internet works. So he has a lot of stuff on this page about how to visualize. You should look right here. How to visualize. Thing is he starts getting into how to visualize algorithms, which, like, it's like, oh, it's pretty cool. You can see like how different selection sorts or merge sorts and all that kind of stuff works, which is in its own right amazing. It's not like totally amazing though. But then you get to already see some really interesting stuff about maze creations. Like this is insane.
That sorting is based on angle.
Yeah, like the lower the number, the lower the angle. So it was doing like a scale essentially for the angle as far as where it was in the array. But this is all randomly being generated. And he has more. There's different algorithms actually produce the graphs, and it shows you how they actually work. Like this is like, I would be happy making one of these as like my PhD, because I'm just not like very good at programming. But he's just knocking these out like cake. I mean, this would be a cool screensaver. And yeah, this is all real-time random. Like this is pre-computed values for different spots or anything. It's like this is all happening. Just made the algorithms and go. Okay, take a look here. So what it's trying to do is it's trying to find its own path. So it's like hits the edge, it's like not good enough, and then bam, go on left. Oh, click way around, reach around, go. Oh, now it's good. Like almost there, come on, you got it, little guy. Now. Thought that was cool. Well, oh. Now just using matrix reversal to fill in the color. Like what? So like this isn't, yeah, like visualization library is a very general term because he's just visualizing. So that's what I'm saying. It's weird to lump this library with graph library. So it's like it's nothing similar. I mean, you can do some of this stuff, but it's not anything. It's not comparative. Can't compare.
So that's SVG, right?
Let's see. Most likely. It could be Canvas because it's a lot of like objects to create to do that.
Is Canvas is all these XML?
Canvas is just it's its own interface. It's its own API. So like when you make a Canvas element, you're in the JavaScript. You can't just say like, hey console or hey Canvas draw. No, you have to first get the drawing context from the Canvas. It's like grabbing a pen, and you can tell it like put your pen down here and then you drag it up to here, and then so it's a lot of raw. If you have like an open GL thing, you go for graphics. So it's a lot of like put thing here and draw line here. But it saves on like if you try to do all these different, like imagine making little objects, little entities for like the SVG colors for all these, you end up with like a Stack Overflow of just like your array space to hold all this information. Whereas the canvas is just like a set chunk for just changing RGB values in there. So it's using different algorithms to traverse the maze and then color it as it goes, which is. He was on his PhD and he stopped because of this. Because he's getting so heavy into this. He's like, I don't need it. So he's an extremely smart person. And what's crazy is, I thought this would be the last thing, but you know something interesting? I had a direct conversation with Mike himself. Don't believe me? Well, let me keep looking at it. So check this out. I'm kind of a big deal. Just saying. Besides all my crappy repositories, the one thing I cherish about my GitHub account is
Got about 5 minutes to get out of here.
where is. All right, just not done. Issues you've dealt with. Does anybody know? Shoot, I may be foiled. Here we go. Yep, here we go. Yeah. So like my 2 issues I've worked with on GitHub was actually D3, one of my 2. So let's go back. Can we scale? Also, there we go. There we go. Look at that. Well, he closed it. All right. Close enough. All right. So yeah, so I found a bit of a typo when I was dealing with. I was looking at some of the point scaling. It mentioned domain. It mentions the variable domain here, but then it talks about the range function. It mentions the domain again here. I was like, it doesn't seem right. And it's like, hey, good catch. And then Mike was like, I'll close that for you. What? I feel like we're best friends now. Just saying. Anyways, that's it.